Hi, so today's video is about factorising, and factorising obviously algebraic expressions. So our learning intention is really to gain a better understanding and strengthening our skills in factorising algebraic expressions. Okay, the success criteria is obviously to correctly factorise by some of these methods, taking out a common factor. So if you can do that. Grouping in pairs. We need to be able to correctly factorize trinomials, and so it's important to know what a trinomial is. And trinomials are things such as x squared plus 2x plus 4. Yep. That's obviously a monic version because the coefficient of x squared, number in front of the x squared, is 1. And non-monics, obviously, if we change it, if it's not a 1, yep. So we need to be able to do that. We want to be able to factorize or create special binomial products. So things such as difference of two squares. Trying to factorize to make perfect squares. You also need to be able to correctly find values of x or find values of the polynomial using the quadratic formula, and using therefore from that you could find you could factorize and write it in factored form, and obviously factorize by completing the square. Some of this, well, most of this stuff was introduced to you in stage 5.3 if you did 5.3. If you did 5.2, I would advise maybe talking to those kids in 5.3 for some help, looking maybe at the 5.3 textbooks from year 10, looking at that to get some more practice. Obviously, the more you do of this, the more practice you get of this, the better you are, and the more fluent and more accurate you become. So practice, practice, practice. So obviously, if you've had enough of using your textbook in year 11, use your textbooks from year 10 if you can get a hold of those. Okay, let's start by doing some examples. Factorizing by taking out a common factor. Here's an expression, -3 minus 9, the common factor between both terms. Negative 3x is one term and negative 9 is one term. The common factor is obviously -3. Take that out, open the bracket. I have to times -3 by x to get -3x, and I've got to times -3 by 3 to get -9. And I really should be able, double check my work, and by expanding it, I should get back to here. So -3 times -3 is -3x, -3 times 3 is -9. That looks very much, yep. So this is correct. I know automatically it's correct. Yep. So checking our work. All right, second example, 7b squared minus 14b. The common factors between 7b squared and 14b, well, there's 7, because 7's in 7b and 4, yep, and b. So 7b times b gives me 7b squared. 7b times -2 gives me -14b, and that's my answer for that one. Okay, 6y squared and 18. The common factor here is going to be 6. Okay, then I've got y squared, 6 times 3. Yep. -3 will give me 18. This is an interesting one because I'll highlight it and I'll come back to it when we talk about some special binomials. So I like that. Okay. Example 4, we've got xy squared minus x squared y. So the common factor is both x and y. So put that on the outside. I times x and y by y to get xy squared, and I times xy by -x to get, negative x squared y. Okay, that's taking out a common factor, taking out a factor that's both in both terms, or there could be 3 terms, there could be 4 terms, but taking that factor out on the outside and then putting what's remained in, what we need times to get back to the original equation on the inside of the brackets. Grouping in pairs. The trick here, what we're trying to do here is we're trying to get something in the form of A, B plus or minus C, plus or minus D, B plus or minus C. The middle things have to be the same. They have to be exactly the same. And if they're exactly the same, I can take that and put it on the side and then collect whatever's on the outside and put that in another bracket. Okay, so looking at this example, just using this part, I can see that the common factor of a squared negative a is a. So if I do that, that's me factorizing, taking a common factor out of those 2 sections. If I now look at this part, I'm going to take a common factor out of here. It's going to be b, c minus 1. Sorry, that's supposed to be a. Okay. And I need that to be a. I need to know. So it's not. I wrote these questions, so it's not that I can just make it up that it's a. It's that I need it to be a to show this example. So you just can't change it if it was a C. But for this example, yes, it's definitely an A. I'm supposed to write down because that makes this the same as this. So the factored form is a minus 1 and a plus b. So taking the common and then whatever's on the outside in its own brackets. Okay. Same idea. So alpha squared plus 7 alpha. The common factor here is alpha. Put that on the outside. Alpha plus 7. What's that part? And then beta, alpha plus 7 beta. So here is going to be beta on the outside and then alpha plus 7. Yeah, they're the same. So that can go out the front. So the first thing I can take. And anything that's in the front of the 2 brackets goes in its own bracket. Okay. So method of grouping in pairs. Yeah, these seems to be in order. Well, sometimes you might need to swap things around so that you can get a common pair. But these ones are in perfect order. So taking out common factors between these 2 terms is 3t. 3t times t makes 3t squared, and then minus 2s goes in there. And then I'll take out 7 from out here. 2 negatives make a positive. So that's 2s, yeah. And there we go. We've got t minus 2s and multiplied by 3t minus 7. Yep. And that's basically that one. Okay. Factorising monic trinomials. To factorise monic trinomials, what we want to do is we want to look at the last term. Yep. Find 2 numbers that multiply to get that, but the same 2 numbers add to make whatever this coefficient is. So we're looking for 2 numbers that multiply together to make the last term, but added together make the middle term. Okay, so here I've got two numbers. So the factors that makes -6. So I'll just write them over here. The factors are obviously 1 and 6. So 1 times 6 makes 6. 2 and 3. 2 times 3 makes 6. Okay, and that's pretty much it. It's a -6. So out of these combinations, one of these digits has to be a negative. So -1 times 6 equals is -6. -6 times +1 makes -6, as you can see. But what we want to do is that when they're added together, make 1. Well, if -6 plus +1, they add together to make -5. So that can't be that. And -1 times +6, add together gives you +5. So that's not, these we don't like. If we had a +2 and a -3 times together would make -6, but 2 minus 3 equals -1. And we want actually positive. So it's going to have to be the opposite way. We're going to +3 and we want a -2. Yeah, so this solution is x plus 3, x minus 2. Yeah, because 3 times -2 is -6, but 3 plus -2 is +1. And once again, we can check this. If I expand, that's x squared, -2x, plus 3x minus 6, so that I did this, and then this, and then this, and then that. Yep. Collect like terms. -2 plus 3 is 1, minus x, and that's exactly what we've got. Yep. Okay, so here's another 6. So we said that the factors are going to be -1, so are going to be 1 and 6. Oh no, it's not going to be 1 and 6 because it is a +6. I have this ability that two negative numbers multiplied together will give you a positive number. So -2 times -3 equals 6. But when they add together, it gives you -5. So the solution to this question is definitely a minus 2 and a minus 3. And once again, you can expand it to double check. Yeah, but -2 times 3 is +6, and -2 plus -3 is -5. Okay. The factors of -12. We have some factors of -12. We obviously have 1 and 12. We have 2 and 6. We have 3 and 4. That's it. So now we want to look at, it's going to be negative, so one of each combination is going to be negative, but added together give you -4. So I feel that it's going to be -6 plus 2. So this solution is going to be x plus 2, x minus 6. Okay, and we can test that. X squared, -6x plus 2x is -4x, and then 2 minus 6 is 12, -12. Beautiful. Okay, all right. Some more examples. Factorising non-monic. So non-monic is when the number in front of the x squared is not a 1. And the way that I do it is I multiply the two numbers, the first term and the last term. So 3 times 3 is 9. So just write over here. And I'm looking at factors of 9 that when they multiply together give you 9, but added together give you 10. Well, that's 9 and 1. And so what I do, I keep 3x squared. I keep this plus 3. But what I'm going to do, instead of writing plus 10, I'm going to actually go plus 9x plus x. Because 9x plus x gives me 10x. Gives me that. And so instead of rather writing 10x, I'm going to just put that there. And now what I'm going to do is I'm actually going to factorize by grouping in pairs. So now I'm going to go, so 3x, x plus 3, by factorizing that part. And here I've got, if I just put plus 1, I get x plus 3. So my solution is, for this one I'm just going to collect what's on the outside, 3x plus 1 first, and then put in the common bracket stuff at the end. It doesn't matter, because it's the same idea of 1 times 2 is the same as 2 times 1. Yep. Okay, second example. 5 times negative 3, well that's negative 15. And we want to get a positive 2. So the factors of 15, obviously 1 and 15, which wouldn't work, and then 3 and 5. So if I start at positive 5 but minus 3, I get positive 2. Okay. So we've got, keep the first, 5x squared. Let's write in our factors. Excellent. Now factorize by grouping in pairs. 5x x plus 1 minus 3 x plus 1, because a positive times by a negative gives me a negative. So our final solution is 5x minus 3 and x plus 1. Close bracket. Okay. So that's the second one. We've got 6 times 6. So I'll write it on the side. I've got 36. And I want to figure out factors of 36. 9 and 4. It's a positive 36. So if I subtract negative 4 and negative 9, I will get negative 13. So let's write that down. 6b squared minus 4b minus 9b plus 6. Taking a common factor here, I've got 2b, which is 3b minus 2. And if I go minus 3, that will give me 3b minus 2 again. Yep, positive 6. And then collect the outside bits and write down the common bracket. And there's your solution. So factorizing non-monics. So our method was, so multiply the first and last, not terms, but the numbers. Yeah. Find factors. Then substitute. And then use the grouping in pairs method. Okay. We want to do practice some factorizing that create some special binomial products, and that's difference of two squares. So when I see something here, I've got x squared minus 5. There's no common factor between x squared and negative 5. But I recall that the difference of two squares, I write down here, a plus b multiplied by a minus b will give me a squared, will give me a squared plus ab minus ab minus b squared. This cancels each other out, and I get a squared minus b squared. This is called the difference of two squares. Okay, and so if I know that, I can see that this is a square number, so this is a square, and this is a square. And what's more importantly, that's a negative sign. So this fits this formula. So the factored form here is the square of x squared, which is x, plus 5, the square of 25, multiplied x minus 5. And that's that factorized. Okay. So I'll do this one, 4a squared minus 49. Well, 40, so it's negative sign, happy with that. 49 is a squared, and so is 4a squared. So I'm going to open brackets. Okay. One's a plus, one's a minus. The square root of 49 is 7. Done. 4a squared is going to be 2a. 2a times 2a is 4a squared. Here, 12. This is 100. Sorry. Can you see? So I put it there. This number is not a square. Okay, not a square. We don't like that. But what I can do is I notice that, yes, I could take out a common factor of 12. Y squared minus 121. Now, I notice that 121 is definitely a square, so I can continue to factorize this down and notice there's a difference 2 squared of y plus 3, y plus 11, y minus 11, because 11 times 11 is 121. Okay, fix that neatly. Okay. All right. This one's an interesting one. This doesn't look like what we're used to as a perfect squared, but this is a square. So if I substituted this as a, for example, a squared minus 16, you would have got a plus 4, a minus 4. Yeah. So the same thing we can do. I'll do s minus 4 plus 4, and and s minus 4 minus 4. Okay, that would be true. I can simplify it further. S minus 4 plus 4, that's going to be that's just going to be s. And then s minus 4 minus 4 is s minus 8. That is a factorized form of that, but obviously if we were to expand that out, we would get to this as our solution. So that's why it's coming up. Okay. Some perfect squares. So we have two perfect squares. We have the square of a plus b squared will always give you the first term squared, the last term squared, and two lots of the terms multiplied together. Yeah. There's also this perfect squared, which will give you the first term squared. The last term squared, so minus b times minus b is positive b. And two lots of the terms multiplied together. And a times a negative b gives you negative ab. That's why you get the negative. So when I look at these types, that's a square of 4. 4 times a is 4a. Double that is 8a. So this is going to be a perfect square, but it's going to fit into this situation. So this is really a minus 4 all squared. I look at this one, that's a square, that's a square. 5, 2 lots of 5 is 10. This is going to be x plus 5 all squared. Here's a negative, so it's going to be a negative sign. Minus 2 times minus 3 is positive 4, minus 2 times y, double that is minus 4, so this is y minus 2 all squared. Yeah, so some of these ones, if you were to do this whole kind of which two numbers, which factors, you'll find that it'll be the same factor, 4 and 4, 5 and 5. Here was 2 and 2. Yeah, so perfect squared. All right. Using the quadratic formula, from the top of my head, I'm not sure if this is on your formula sheet. Some of you were introduced to this in year 10. It's one of those ones that you should remember. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. What are b, a's, and c? Well, in the general quadratic, we have a equals ax squared plus bx plus c. That's the general formula. So if I write the general formula here underneath, we can tell that for this one, a is 3, b is 10, and c is 3. So if we were to write that into our quadratic formula, this is a formula that will always give us our solutions. B is 10, so we've got negative 10, plus or minus the square root of b squared, 10 squared, minus 4 lots of a is 3, and c is another 3, over 2 lots of a, and a is 3. Okay. Big complex problem to solve. But that's why we got our trusty calculator. Yep. Okay. So I've got minus 10 plus the square root of 10 squared minus 4, 3 times 3 over 2 times 3. Okay. I've got a plus here. Yeah. So x equals negative a third. But that's only one solution. What I've got to do is go back to my quadratic formula and change that plus to a minus, because it's plus or minus. Okay. And so we get these two solutions. So to factorize, I'll do this part first. Well, okay. Okay. We could do x plus a third, x plus 3, and that, notice that I've changed those signs to a positive, because when x equals negative 3, I'll get 0. And when x equals negative 1, I'll get 0. usually this would tend to be written like this: 3x plus 1 and x plus 3. And the reason why is because if this was to be a null factor, we would have gone, so if I wrote that as a null factor, just write it, I do it over here, 3x plus 1 equals 0, 3x equals negative 1, x equals negative a third. And that's where you're getting that from. So the quadratic formula finds the values for x. Yeah, so in order to put it into your factorized form, you have to change the signs. Okay, difference of two squares. Okay, we could still use this. So here we've got a is worth 1, b is worth 0, and c is worth negative 4.6. Okay, so if we were to plug that into the formula, we've got x equals negative 0 plus or minus the square root of 0 squared minus 4 lots of 1 negative 4.6 over 2 lots of a. Okay, so b is 0, so it doesn't matter, plus 0 squared, doesn't matter, minus 4 lots of 1 times negative 4.6, and then over 2 times 1 is 2. So we get this value of x equals 2.14 two decimal places. And now I've got to go back and get the negative version, subtraction version. So minus 2.14, they're the same. Okay. So therefore, if I was to do factorized forms, we'll do it over here. We've got something along the lines of x plus 2.14, x minus 2.14 approximately. Yeah. Let me just sort this out. So 4 times negative 4.6 is negative 18 point, no, sorry, negative 4 point, so here we've got, if we did surds, we've actually got the square root of 18.4 over 2, plus or minus. That'd be 9, so that's also equivalent to no. Yeah. So really, so the factorize we could actually do is x plus square root 18.4 over 2, x minus 18.4 over 2. Yep. If we wanted to insert form. Okay. Here we'll do this one. Okay, so here a is obviously equal to negative 1, because there's a 1 here. B is worth negative 4, and C is worth 9. Okay. Using the quadratic formula, we've got negative 4. That's going to be so it's going to be a positive. Yeah. Plus or minus the square root of negative 4 squared minus 4 lots of A, which is negative 1, lots of C, which is 9, all over 2 lots of negative 1. So we've got negative 4 plus the square root of negative 4 squared minus 4, negative 1, and 9 over 2 lots of -1. Note that I've put in the negatives. It's so important, because obviously if you times a negative with a positive, it becomes a negative, but if you times two negatives, they become a positive. So our first one's -5.61. Okay, and go back and change that to a subtraction sign, and we get 1.61. So we have approximately x plus 5.61, x minus 1.61, approximately, if I was to factorize. Okay. Yeah, at the end, factorizing by completing the square. So if we have something like this, there's no factors of 2 that multiply together will give you -4. So what I'm going to have to do is complete the square. So what I do is I bring this value to the other side. So I move the integer, or the c value, to the other side. So I assume that it's set to 0. Yeah. So I move it to the other side. I basically then try to complete this square. Yeah. And so what I do is I basically halve the b value and square the result. And that's due to the fact that a plus b squared is the first term squared, the second term squared, and 2 lots of the both terms multiplied together. So basically what I'm going to do is going to halve that. So -4 divided by 2 is, so I can do it over here. So -4 divided by 2, and then I'm going to square it. So -4 divided by 2 is -2. -2 squared is 4. Okay, and then what I'm going to do is I'm going to add that 4 to both sides. And that's just to balance the equation. Yeah. So very important to add result to both sides. Okay. Now I can factorize this. Okay, so x squared minus 4, that's just going to be x minus 2 all squared. Yeah, so -2 plus 4 is +2. Yeah, just adding those two numbers together. Okay. Now, set the equation to 0. And that's by bringing back the integer. So, bring back the integer. Alright, so we've got x squared minus 2 all squared. Bringing that back was subtracting 2. Yep. Now all of a sudden with this one we actually now have a difference of 2 squares. The square of that is going to be the square root. Yeah. So we've actually got so I'll do a big brackets, small bracket, small x minus 2 plus square root 2 and x minus 2 minus square root 2. Yep. And that's our final answer. Okay. Let's follow the steps here. So we're going to set it to 0. Yeah. We're going to move the 3 to the other side. I'm going to halve 6. I'm going to square the results. So that's going to be 3 squared, which is 9. Alright, so I'm going to add them to both sides. So this is a perfect square, so x plus 3. And that's going to be minus 3 plus 9 is 6. Yeah, going to bring it back. X plus 3 all squared minus 6. Difference of 2 squares. X plus 3, if I do it in big brackets, plus square root 6. And x plus 3 minus square root 6. Some of you might be asking why it's square root. Well, 2 square roots give you a positive. That'll give you the whole. Okay. Step 1, let's move it to the other side. Let's halve that first, the b value, so it's negative 1 over 2. I'm going to square it. That's going to give me, it's half, it's going to be a quarter. So let's add that to both sides. So this will be x minus a half squared, and this is 1 1/4. X minus a half squared minus 1 1/4 will equal 0. And I can keep going. I can do that as well. But then that's it. So there are a couple of methods to factorize algebraic expressions. Obviously, go through them. As I said, the more we practice, the better we become. So hopefully you can factorize trinomials, take common factors, grouping pairs, realize what difference of 2 squares are and perfect squares are, factorize using the quadratic formula, and factorize by completing the square. So thank you very much.